over the study guide for our Touchstone EE1 and 2, EE7A, and NS1. So the first part of this is going to be over rational and irrational numbers. Remember that rational numbers can be written as a fraction or a repeating decimal, and irrational numbers cannot be written as a fraction, are not perfect squares, and are infinite non-repeating decimals. So if we look at number 1, we have 2.5467 ... which means it continues without a pattern. So this is an irrational number because there is no pattern, or it's not repeating. And it's infinite. Now we're going to look at number 2, and I just want you to identify the numbers as rational and irrational numbers. So -4 is a rational number. It's an integer. 0 is rational. 1/4 is rational because it's a fraction. Now, the square root of 9 over 4 is a perfect square because 9 is a perfect square and 4 is a perfect square. Therefore, it simplifies to 3 over 2, which is a fraction, so it is rational. If we go to B, 0 is rational. 1/2 is a fraction, so it's rational. 1.5, terminating, stopping decimal, is rational because I can write 1.5 as a fraction. The square root of 8 is irrational because it is not a perfect square. Over to C, -2 is rational. 1 is rational. Both of those are integers. 2.6 repeating is rational because we can write repeating decimals as a rational number. Now the square root of 3 over 2 is irrational because the square root of 3 and the square root of 2 are irrational numbers. And or D, 0 is rational. 0.36 repeating is rational. 4 is rational. And the square root of 24 is irrational. So those are our rational and irrational numbers. Now if we move down to number 3, again, identifying rational and irrational numbers. I'm just going to go through these answers quickly so you can check your work. 1/3 is a fraction, so it's rational. 0.125 is terminating, so it is rational. The square root of 49 is a perfect square, so it is rational. And the square root of 54 is irrational because it's not a perfect square. Now, how do we write 5 over 9, or 5 divided by 9, as a decimal? You can do this in your calculator by putting in 5 divided by 9, and you get 0.55 repeating. 8 divided by 9, type it in just like you read it. 8 divided by 9 is 0.8 repeating, or 0.88 repeating. Notice on your calculator that it ends in a 9. That's just rounding up the infinite repeating decimal. So then if I were to write 5 over 9 minus 8 over 9 as a decimal, I would have 0.5 minus 0.8. And don't forget the repeating sign on both of those. For number 5, it says explain why the following expression is equivalent. So I have the fraction 1 over x to the 3rd power is equal to x to the -7 times x to the 4th power. Well, we know when we multiply exponents, we are adding them. So -7 plus 4 equals x to the -3. Well, we know when we have a -3 in the numerator, it's not happy, and we have to take the reciprocal of that and write 1 over x to the 3rd power, and therefore you have proven that these are equivalent. Moving on to number 6, it says the cube has a side length of 3x squared y4. What is the volume of a cube? So it's telling you that volume equals the side length cubed. Well, if the side length is 3x squared y4, then I am going to cube that in order to find the volume. When I have an exponent on the outside of the parentheses, I have to distribute it to everything inside the parentheses. So I end up with 3 cubed. Remember, we're going to multiply our exponents. So we have x to the 6th power, y to the 12th power. And I can simplify 3 cubed as 3 times 3 is 9. 9 times 3 is 27. X 6, y 12. Moving on to number 7. Pause the video at any time to finish answering the questions, then check your work. This time they give you the volume and they want to know the side length. So what gave us the answer of 8? So you're going to take the cubed root of 8. So on your calculator, you're looking for the cubed root symbol, and then you're going to type in 8. Another way to look at that is which one of these answer choices, if I multiplied 3 times, so 2 to the 3rd power, or 4 to the 3rd power, or 8 to the 3rd power, or 24 to the 3rd power, which one of these gives me 8 as my volume? And the answer is going to be A. Now I'm going to write the equivalent to the square root of 81 over the square 121. Well, 81, the square root of 81 is 9, and the square root of 121 is 11. So an equivalent fraction would be 9 over 11. For number 9, notice we're doing a cube root. So what multiplied 3 times gives you 27 or 64? And the cubed root of 27 would be 3, because 3 times 3 times 3 is 27. And the cubed root of 64 would be 4, because 4 times 4 times 4 is 64. Number 10 says a square has an area of 36 square miles. What is the perimeter of the square? Well, area is always squared. So I'm going to do the opposite of squaring 36. If the area equals 36, then what does the side length have to be so that something times itself equals 36? So I'm going to take the square root of 36, and that means my side length is 6. But perimeter is when we add up all the side lengths. So if I have a square and each side is 6, and I add up all of those 6's, I should get 24. Now, Sarah bought cookies for her grandmother. The cookies were half off the original price. You paid $2.10 in sales tax, and you received $3.50 in change. If you paid with a $20 bill, what was the original price? Okay, so we know that X is going to stand for the cost of the cookies, and it was half price. We also know that he paid $2.10 in tax, plus he got $3.50 in change. That has to equal the $20 bill that he had. So now you're going to combine your like terms and get 5.60 equals 20. Now you're going to subtract 5.6 from both 60 from both sides. Make sure you're lining up the decimal place if you're doing it by hand. Or in your calculator, you're going to do 20 minus 5.60, and we get, I'm going to move up over here, x over 2 equals 1440. And then, because this is x divided by 2, we're going to multiply by 2 on both sides, because that's the inverse operation. So 1440 times 2 is going to be 28. So x equals 2880. So that means the original cost of the cookies was $28.80. For number 12, it says a plumber charges a flat fee of $25 to come out for a service call and an additional $10 per hour that they work. If the bill for the service call costs $45, write the equation to represent the service call. So the flat fee is what we started with, plus an additional $10 per hour, which is our variable, equals the total. And that would be your equation. 25 plus 10x equals 45. Number 13, what is the solution to this problem? I'm going to rewrite it so I have some room. So we have 2x plus 4 equals 2 parentheses x minus 2. First, get rid of the parentheses by distributing 2x minus 4. Because 2 times x is 2x, 2 times negative 2 is negative 4. Bring down the 2x minus 4. Notice that if I move my 2x, it doesn't matter which way I move it, they're going to cancel out and the variable is gone. And I end up with a positive 4 equal to a negative 4. This is an incomplete, incorrect answer, so there is no solution. If you came out to two answers that were the same thing, then it would be infinite solutions. Now looking at number 14, we're dealing with decimals, but that doesn't mean we can't solve the problem. So we have 2.5x plus 3 equals 0.5x minus 5. So I'm going to subtract 0.5x from both sides so that I get 2x plus 3 equals negative 5. I'm going to subtract 3 from both sides and get 2x equals negative 8. Divide by 2, so x equals negative 4. Number 15. It says the sum of 3 times a number and 5 is 20. What is the number? So we're converting this sentence into a problem, an equation. So sum means to add 3 times a number. So a number is my variable. So 3 times a number would be 3x. We know it's addition, so I'm going to add 5. Is means to equal 20. So here's my equation, and I'm going to subtract 5 from both sides. I get 3x equals 15. Divide by 3, so x equals 5. So the answer was what is the number, and the number is 5. The last part is our laws of exponents. So for number 4, it says 1 over x to the negative 4th, which means it's not happy in the denominator. We need to do the inverse. So negative means inverse, which is going to be flipping it over, and we get x to the 4th power over 1, or just x to the 4th power. Moving across, this says 9 to the negative 1 power, and a to the 1st power. A is happy in the numerator, but 9 is not. So I'm only going to take the reciprocal of the 9, so that I get a1 to the 1st power over 9 to the 1st power, or just a over 9. Now, for number 6, moving across, this is x to the 4th power divided by x to the 9th power. Because it's a division of like bases, we're going to say 4 minus 9, and we get x to the negative 5th power. But because it's negative, we have to take the reciprocal, and it's going to be 1 over x to the 5th power. Now, for number 7, we have lots of things going on here. First, I'm going to take care of the numerator, and this is x to the 4th times x to the 3rd, so I'm going to add 4 plus 3, and I get x to the 7th power. In the denominator, I'm going to go ahead and do my power to power, which is x 4 times 3 is going to be x to the 12th. Now, this is a division problem, so I'm going to subtract 7 minus 12, and I get x to the negative 5th power. And then I'm going to write the reciprocal, because we don't like the negative exponents, as x to the 5th power. 1 over x to the 5th power. Now, for the next problem, we have to take care of this outside exponent first, and it's only going to distribute to the inside of that set of parentheses. So 2x to the third power stays the same, and then I'm going to end up with saying negative 5 squared is a positive 25x squared. Now I can multiply 2 times 25, and I get 50. And I'm going to add my exponents and get x to the 5th power. Number 9, I'm going to go ahead and subtract my a exponents and subtract my x exponents. So I'm going to say for a, negative 5 minus 4 is a negative 9. So a to the negative 9. For x, x is 2 minus 3, which is x to the negative 1. Since both of those are negative, they're going to go in the denominator, and my answer is going to be a9x1. 1 over a9x1. And number 10, we have to distribute the power of 3, so that we get 3 to the third power times x to the negative 12th power. We're still going to multiply, and it's still going to be a negative exponent. 3 to the third power is 27. The 12 is not happy, so I'm going to put it in the denominator. And my answer is 27 over x to the 12th power. Now we have number 15. We're just going to simplify 15 over, number 11. 15 over 10. Can be simplified by dividing 15 by 5 and dividing 10 by 5, so that we get 3 over 2. I'm going to subtract my m exponents, which is 4 minus 7 is a negative 3. Because it's a negative 3, I'm going to leave m in the denominator with a 3 exponent. There's an understood 1 with the n, so 1 minus 3 equals negative 2. Because it's a negative exponent, it goes in the denominator, n squared. Number 12, distribute the negative 2 exponents. So we have 5 to the negative 2, x to the negative 6. Because they're both negative, we're going to move them to the denominator and do the reciprocal. 5 squared is 25, x to the 6th power. And number 13, anything raised to the 0 exponent is 1. Now I have a negative 2, y to the negative 2 is not happy, so I'm going to do the reciprocal of just the y, and it's going to end up with y squared over 7. And our final problem, 9 is happy in the numerator, 4 is happy in the numerator, but then we have to add negative 4, which gives us 0. So 9x 0. Well, the x to the 0 becomes 1, so 9 times 1 is 9. Hope this helps. Watch the video as many times as you need to. Pause the video, and hope you're ready for your quiz tomorrow.